Welcome to What That Means with Camille, where we take the confusion out of tech jargon and encourage more meaningful conversation about cybersecurity. Here is your host, Camille Morhart.
Hi, and welcome to this episode of What That Means. Today we're going to cover artificial intelligence trustworthiness, or decentralized artificial intelligence and its trustworthiness. I've got three professors with me today who are part of the Intel-sponsored Private AI Collaborative Research Institute. I have with me today Farinaz Koushanfar from University of California, San Diego. I have Asokan from University of Waterloo and Ahmad Sadeghi from University of Darmstadt. We're going to get into a conversation about everything having to do with security and artificial intelligence, pretty much everything from software down through the hardware layer, and also talk a little bit about what's at the frontier with respect to privacy and ethics in this space today. So welcome the three of you to the show. Today's conversation, we're going to talk about artificial intelligence and specifically security with respect to it. And then I think we can dive in a little bit deeper as we go and talk more about the different kinds of models of artificial intelligence, whether they're centralized or decentralized, and how maybe that changes security and what you three are looking at from that perspective. But somebody help me out here. Can somebody give an overview of the ways that artificial intelligence is adapting to improve security in general?
We are at the brink of the next industrial revolution, which is rightfully called the automation revolution. And this is enabled by the power of artificial intelligence. We see now many things that have been done manually in the past are now getting automated. And this automation is done by the power of AI algorithms and learning from the data that we see from them. So this automation and this revolution in automation that is enabled by the AI is of course also happening in the area of security and privacy. So we are using algorithms that are smarter, more intelligent to automate the security and privacy processes. But as we are using these engines, these artificial intelligence is really an engine for automation, there's also another side to it, and that is your engine reliable? Is it secure? Can somebody take out this engine and try to do malicious things to it? Or when you're training your engine to do these automated tasks, can they actually impact it to make wrong decisions? Because now all the decisions are automated. There are still scenarios of human-bot interaction, which is another frontier of artificial intelligence. But this is really what is happening. On one hand, we are automating many processes, including security and privacy processes. On the other hand, the artificial intelligence itself has vulnerabilities that we need to specify. And last but not least, this abundance of data and abundance of models is also exposing a lot of sensitive information from people. So there's also that privacy risk involved.
The artificial intelligence in 80s, as I was a young student, I was fascinated by neural networks, but this is not really new what we are talking about. The technology has changed, automation has changed in that sense, because we have the basic technology for it. We have better and more efficient hardware and also software. So there are lots of technological advancement that brings us to another reincarnation of AI and the hype of AI. These so-called artificial intelligence, they are getting integrated into many decision-making processes. And it doesn't mean at all that these decisions are the right ones. There are lots of security holes in these algorithms because they are not made with security in mind, and they can be simply manipulated. And that is where I am very much interested in, usually from a more destructive side, because I believe that AI will be a big danger for something that I call it AI medic, like pandemic. It will be bringing all of us into a crisis, a digital crisis, where the decisions that these neural networks or whatever they are not clear to any human being. We cannot verify it. We cannot really understand it. And Those who want to manipulate it can manipulate it. I'm talking about Wall Street. They are doing it manipulation for many years, but now they have more powerful tools. So looking at it from a destructive side, I would prefer to look into the weaknesses rather than strength.
And what defines system security is thinking about how to secure systems in the presence of what we call an adversary, meaning that somebody like a human being who is trying to undermine the system using all the powers of intellect that they have. So I started getting involved with machine learning and security initially purely as an application area, like how can I use machine learning to improve security and privacy? And this is something that has been done for like more than 3 decades. But what's different about how we approach problems is that we don't just apply machine learning to get a faster, better solution, but you also think about what would the bad guy do to undermine our solution. And this is something that machine learning and AI people normally don't do. So I could give an example. Think about like a face recognition system, right? So we want to have a system that will recognize our faces correctly as belonging to ourselves. So an AI expert would say the way you would validate the system is to collect 10 images from my face, 10 images from Ahmad's face, and Farinaz's face, and so on, and then show that my face will always be recognized as me, Farinaz's face will be always recognized as her, and my face will not be accidentally recognized as Ahmad's face. This is where they will declare success. But if Ahmad is trying to break the system, he's not going to oblige us this system by using his face to pretend to be me. So he's going to do things like he's going to wear glasses, or he's going to put makeup on, or wear lipstick or something like that, so that he would look like me. And this is an aspect that hasn't been taken into account in AI-based systems. But AI is everywhere, not only in security, but in human resources, in jurisprudence, in policing. So making mistakes here and designing systems that can be easily circumvented is going to impact us in ways that we haven't imagined before. So that's how we pivoted from not just figuring out how to use AI to improve security and privacy, but studying how to make the AI-based systems more robust and more trustworthy.
As a security researcher, we also recognize that the standard security aspects not always apply to AI in general, because we need to get into all these neural networks to understand, because they have, like the human brain, they may have many layers. We cannot really understand sometimes the information that goes from one layer to another layer and again another layer. And because of this, we cannot immediately say, okay, we have standard solutions for that. There is a lot of room for research to apply to AI systems in general.
Do we have to actually be able to explain the AI in order to be able to protect it? Or are we able to somehow come up with protection mechanisms still without understanding truly how it's working underneath?
The explainability aspect is very important, and it's also a hot topic of research. According to some of the recent studies by some consulting companies, many companies, around 40%, they don't know what is the use of AI for their business, daily business. But more than 90% of all the CEOs of small size, mid-sized, and big companies in Germany, take Germany as use case, they are extremely concerned about the explainability. They want to know what happens if I cannot explain what is happening. So how can I have assurance about the trustworthiness of these algorithms?
We are right now in this stage where we apply AI. It works great. We don't quite understand how. And there are companies, big and small, are trying to sell this and make money out of that. But explainability and interpretability are important, like Ahmad said, but I don't think it's even going to be a choice that we can make. I think 10 years down the line, governments are going to require us that we cannot deploy systems without being able to explain, because there are issues like fairness that come into play. So I would imagine that the next iteration of privacy regulation or data protection regulation, like the European GDPR, might include strong aspects of explainability and interpretability. If you can't explain why you are making some decisions that are going to be used in recruitment or deciding who gets parole and so on, then you can't deploy them. I think that will be enforced by policy, and this is not going to be a matter of choice. It's going to be a requirement.
So, Farinaz, would you be able to help us understand some of the security perspectives? I know you work with helping to secure at the hardware level, I'll say decentralized artificial intelligence and algorithms. Maybe you can explain kind of what those are and how you're looking at that.
I'm really a systems person, so the solutions I have goes all layers of the system. You could think about securing a system, any system, including systems that have AI in them, as securing your house. If you want to secure your house and nobody comes in, what do? You can close all the windows and all the doors and try to just shut down everybody from coming, but that's not practical. The truth is, in securing computer systems, the story is exactly the same. The vulnerabilities are really at the interfaces. And if you have a system where you have these vulnerabilities at the interfaces, then people can attack your system and try to get that secret from the interfaces. I really think hardware also has a role in making things much faster, much more efficient, because right now, to make artificial intelligence more efficient, there is a lot of accelerators out there. A lot of these accelerators actually are not very robust and reliable. One part of the research that I'm doing, which interfaces this, is when you make your AI models more robust, be it distributed AI models or centralized AI model, can you simultaneously make sure that this robustness doesn't add to the overhead of your system, that you could do this robustness in real time, and you could have an end-to-end system that performs really, really well.
So at the most basic level, you're basically saying encryption or various forms of encryption or similar hardware level protection or software level, algorithm level protection can tend to slow a system down. Not always, but often. And so part of the role then is to improve the performance once you've done that encryption.
Yes, and security and robustness here, definitely in terms of AI systems, goes far beyond encryption. For example, adversarial attacks to AI systems, where people are providing instances that look legitimate, but they're actually fooling the model to make a wrong decision. The reality of it is that AI systems are working based on gathering a lot of data and extracting statistics about it. And at the end of the day, we are as good as the data that we get, and we are as good as the model that we learn. The problem with learning these models is that the space of what you're trying to learn is really huge, and AI models are trying to build a lower dimensional representation of really a huge dimensional space. And when they try to do that, if they don't have enough data in all corners of this multidimensional space, if there is added noise to the data, if the AI model building itself is not well regularized, then these models don't have the very well-defined boundaries that are always correct. And then attackers use that to construct samples that have a little bit of structured noise in them. So the input looks like really legitimate because, for example, in terms of the picture, you can see a picture of a cat that looks exactly like a cat, but it has a little bit of noise in it, which is not detectable, say, by human eye. Then the AI models, they could classify this as a car. That's kind of a really nefarious attack, because just imagine projects in the auto industry where these algorithms are making real-time decisions as your car is driving. Now, no longer just a cat versus dog versus horse mistake, but it's a dynamic attack on a cyber-physical system like a car that can have really nefarious consequences. And there's a lot of beautiful theory about adversarial attacks, and there's a lot of nice algorithms try to avoid adversarial attack. But one aspect that we've uniquely introduced, and we've been working on it for now about 5 years, is how do you make these solutions integrated all the way from system level all the way down to hardware, so that you could actually detect them in real time without impacting the performance of the AI system, which by itself is quite intense on the computational resources that we have, which is why a lot of companies so far have been focusing on building accelerators. And now just imagine you need to use these accelerators in your automotive system, but these are not very robust. If you try to introduce robustness, you lose the real-time aspect of detecting things. So this is another big aspect of how hardware can be used, and there is more and more awareness of that.
At some level, adversarial examples like this are fundamental. It's not a problem with just AI-based systems, but any system that tries to build a model that approximates reality. So human brains are no exception. Optical illusions are adversarial examples against the human brain, where something that looks as if it's a square is in fact a circle or something like that. So all of us are familiar with optical illusions, and they are exactly the same. They arise out of the same theoretical considerations that Farinaz explained. So at some level, you can't avoid them, but you can do better by detecting them or compensating for them by looking at the system as a whole and not just the model that's at the heart of the system.
Well, I have to say, when you're talking, I'm thinking this is horrifying. This thought of real-time traffic direction or functional safety system that's using automation to enhance decisions and actions, or maybe even taking action autonomously. So help me understand, how far are we from having something that we can consider secure, or is this just very, very early?
We are very far from when you come to the safety and liability of an industry. We are far away from those cases where regulators allow you to put a car or put a vehicle on the street, where this vehicle is connected to a cloud and to other vehicles, and it's a self-driving car, or even without any drivers in it. And when we are there, then the safety of many human beings will rely on that. The problem is dependency. If a whole country is dependent on a communication network that's provided by a specific company, then that company has overall the control of this communication and can be misused, either because the company wants to make money or because the governments are misusing that. So this is a sword which has a side which I think is sharper than the other side.
So in that sense, I'm optimistic. I trust human ingenuity that we are still in early stages of AI-based systems. Eventually, I think humanity as a whole will figure out how to do these properly. So things that look scary now would be harnessed and then would be used in the right way a decade or 2 decades down the line.
Are there specific things that you three are looking at that are not kind of well known in the world when you consider security and AI?
I was talking about one of them, which is looking into full stack solutions for an accelerated robust AI, which is something rather unique. And robustness has multiple facets to it. We talked about this inference time. And there is also the big aspect of data poisoning, where people who are trying to, say, collaboratively learn, some of them is trying to poison the data to revert the models in a way that is doing something malicious for them. Just the confluence of all these objectives, from privacy, security, robustness, in one system that has to work consistently and efficiently, that I really think is really one of the frontier challenges of this.
Yeah, I can give an example of something that one of my postdocs is doing. He's trying to answer the question, what do deep neural networks really learn? Are they learning rules? Are they learning the ability to do symbolic computation? Or are they just doing association, essentially like statistics on steroids? And I think he's not alone. There are others who are looking at this, kind of fundamentally understanding what are these things learning, even though a lot of the publicity and glitz is on, look, Ma, what are neural networks capable of doing? They're doing fantastic things, but understanding why, how they work is going to pave the way for interpretability, explainability, and so on. Perhaps not enough people are working on that because the applications and showing sort of dramatic improvements is so much sexier than trying to understand how neural networks work. But I think that's an important part that is sort of evolving now. Many people are starting to think about the basics of what's under the hood and trying to understand that.
One thing that I was thinking about for a long time was about the poisoning of data or the models. So if we have an algorithm that we push it through another algorithm and that mitigates the poisoning, assume that we have that. So the question is, can I have a filter that I push any algorithm that I want to sell you. So for example, for recruiting, somebody comes like Amazon or anybody else comes to you and said, buy this. This is my algorithm. It's good for recruiting. If 10,000 of people apply for a job, this can decide for you, at least the first phase, before a human HR look at it. And then I say, but how do I know that it's fair? So you have to provide data. I have to check it. All these kind of things is very messy and it's not efficient. So how about I have a filter? I push your algorithm through my filter. And then it becomes a kind of, I add so much noise that is not bad for the accuracy, but it is enough to obfuscate certain aspects of this algorithm that may be unfair. And I think this is just an idea, but we are starting very small because there is a big research community on fairness, especially when you want to define what is fair, what is not fair. It's very complex, especially if it comes to the legal aspects, like when you go to a court, how do you prove what is fair, what is not fair? And that fascinates me because it has to do with a number of disciplines that you need to work with it. It makes it more challenging. So this is the known unknown that I personally am very interested to look into.
My God, we've covered a lot today. Fairness, privacy, security, decentralized, centralized, federated learning. We've looked at full stack and the interest in that and explainability and its relevance. I really appreciate the conversation. Thank you, Asokan, Ahmad, and Farinaz for joining me today. And I hope to have more conversations about AI and security in the future.
Never miss an episode of What That Means with Camille by following us here on YouTube. You can also find episodes wherever you get your podcasts.
The views and opinions expressed are those of the guests and author and do not necessarily reflect the official policy or position of Intel Corporation.